What if the key to understanding our own evolution lies not in Africa's heartlands but scattered across forgotten islands and silent caves of Asia? What if the giants, ghosts, and tiny hobbits of our past were never outliers, but the true keepers of humanity's story? Beneath the jungles of Indonesia, the icy plateaus of Siberia, and the dusty riverbeds of India, clues whisper of a different genesis, one in which human evolution was not a straight line, but a labyrinth. And as we follow those whispers, the truth becomes stranger, deeper, and far more human than we ever imagined. The search for the true shape of our evolutionary tree has never been a neat tale of progress, but a story told in fragments, bones and whispers of ancient lives scattered across time. Each fossil unearthed adds a shard of clarity yet deepens the mystery, revealing that humanity's origins are less a ladder and more a tangled vine. Among the most haunting of these clues are the Denisovans, once nothing more than genetic ghosts glimpsed in strands of DNA and a few shattered bones too incomplete to reveal a face. For years, they were shadows in our lineage, known not by sight but by sequence. Then came the discovery of Homo floresiensis, the tiny hobbit of Flores, so strange that many scientists dismissed it as an evolutionary error, a malformed descendant of modern humans rather than a people in their own right. But as the dust of skepticism settled, the evidence refused to fade. The hobbit was no mistake. It was a revelation, a living contradiction that forced us to reconsider the entire human story. For decades, textbooks told us that Homo erectus arose in Africa around 2 million years ago and journeyed outward, spreading across Asia like explorers on a one-way voyage. But the fossils of Flores and the silent record of Denisovan DNA whispered of another possibility, one in which Asia was not merely a stage for migrants, but a cradle of innovation, a parallel birthplace of humanity's many forms. At Minisi in Georgia, bones dating back 1.8 million years blend primitive jaws and small brains with erectus-like skulls, as if evolution itself was experimenting, reshaping, and remixing its designs. In China, the ancient teeth of Yuanmu and the fragments of Gongwangling, both older than 1.6 million years, tell of an early human presence too ancient to fit comfortably into the old narrative. On the islands of Java, fossils from Sanjiran whisper of Homo erectus thriving by 1.5 million years ago. All of this evidence, from Georgia to Indonesia, points to a stunning truth. Asia was never empty, never waiting for Africa's emissaries. It was alive with early humans, diverse and adaptable, testing the limits of form and endurance. And yet, as we compare those finds with Africa's fossil record, a puzzle emerges, one that turns our cherished map of human migration upside down. The African fossils of Homo erectus, often called Homo ergaster, are not much older than those in Asia. In some cases, they appear younger. Could it be, then, that the first true Homo erectus emerged not in Africa but in Asia? Could the great backflow of humanity and exodus in reverse have carried Asian descendants back into Africa, where they would eventually give rise to new species, perhaps even us? The idea challenges everything we thought we knew, yet the evidence from Flores strengthens the case. The hobbits, with their tiny bodies and brains no larger than a chimpanzee's, retain features far older than erectus, wrists and shoulders reminiscent of Australopithecines, feet that bridge the ancient and the modern. Their anatomy is a mosaic of past and future, suggesting descent from an early Asian population that branched away before erectus reached its final form. Isolated on the island of Flores, these small humans evolved in splendid seclusion, their size shrinking as the island's resources demanded efficiency over strength. They hunted pygmy elephants, crafted stone tools, and lit fires to push back the darkness, proof that intelligence wears many shapes. Their existence forces us to see that human evolution was not a straight climb toward modernity, but a series of branching experiments, each shaped by geography, climate, and chance. If Asia gave rise to erectus, then Africa may have been just one of its laboratories. Not the birthplace, but the workshop where returned wanderers thrived. The fossil record supports this tangled possibility. Flores reveals the survival of primitive traits deep into the recent past. Java shows the persistence of robust erectus forms, and the Narmada skull of India thick-boned, large-brained, and enigmatic sits at the intersection of these lines, bridging the small and the giant, the primitive and the advanced. For years, scientists argued over Narmada's identity. Was it a late Homo erectus? An early Homo sapiens? Or something entirely different, a regional variant of a species that refused to fit into boxes? Its skull bore the strength of archaic humans but a cranial capacity nearing our own, a blend that defied classification. And then, as new tools emerged, the puzzle began to shift. Using a method called gene regulatory phenotype profiling, researchers began to predict how Denisovan skulls might have looked, mapping their genetic instructions for bone growth, face shape, and cranial form. Out of these invisible codes, faces began to materialize massive, broad-skulled, distinct from both Neanderthals and us. When these virtual Denisovans were compared to the fossil record, 3 skulls stood out: Harbin, Dali, and Kabwe. Harbin, known as the Dragon Man, has since been genetically confirmed as Denisovan, validating the method. Dali matched almost perfectly, and even Kabwe in Africa, far removed from the Siberian caves of known Denisovans, showed a remarkable resemblance, hinting that this ancient lineage once stretched across continents. The Petrolona skull from Greece, too, bore similar traits, suggesting that Denisovan-like humans once ranged even into Europe. For the first time, the Denisovans had a face, and it was not confined to one land but scattered across the old world. In this new light, the boundaries between species blur further. The Middle Pleistocene, once called the muddle in the middle, now appears as a vast web of overlapping populations, interbreeding, evolving, and diverging in a dance of survival. It is within this intricate mosaic that the hobbit of Flores and the skull of Narmada take on new meaning. The hobbit, once seen as an evolutionary joke, is now understood as a testament to adaptability, a Homo erectus lineage sculpted by isolation into a new form. The Narmada skull, by contrast, represents the opposite extreme, a lineage of Asian erectus that grew larger, stronger, and perhaps smarter, thriving in the wide plains of India. Together they form a living spectrum of possibility: tiny islanders, giant plains dwellers, and ghostly Denisovans, all descended from the same ancestral stock that left Africa nearly 2 million years ago. Each evolved along its own path, shaped by geography's hand and evolution's unending creativity. As we trace their stories, we begin to see that Asia was not the edge of the human world, it was its heart, a crucible where erectus became many things at once. And as we stand today, piecing together their bones and decoding their genes, we are not just reconstructing faces from the past. We are recognizing ourselves in them. For the hobbit's delicate hands, the Narmada skull's mighty brow, and the Denisovan's unseen gaze all carry the same message: that humanity's story was never about one origin, but about countless beginnings braided together by survival, curiosity, and the unbreakable thread of life itself. When we peer deeper into the genetic record, the illusion of clear boundaries between human species begins to dissolve like mist. The more we uncover, the more tangled the story becomes. Once, scientists imagined a linear succession, one species replacing another in an orderly march toward modern humanity, but DNA has rewritten that tale in shimmering, unpredictable patterns. Hidden within our genomes are faint signatures of long extinct relatives, echoes of encounters that took place not once or twice, but again and again across 1 million years of migrations and meetings. Neanderthals and Denisovans were only the most recent of these ancient partners, yet they were far from the first. Before them, long before modern humans even existed, their ancestors, the Neanderthals, met and mingled with an even older population, a people we now call the superarchaics. These were not just another species of early human. They were survivors of the earliest waves to leave Africa, perhaps descended from Homo erectus or an even more ancient form that set foot in Eurasia nearly 2 million years ago. For over 1 million years they lived apart, evolving in isolation while their distant cousins elsewhere continued to change. And yet, When the ancestors of Neanderthals and Denisovans spread across Eurasia around 700,000 years ago, they did not find an empty continent. They found the superarchaics waiting different, ancient, and yet still human enough to recognize, to communicate with, and ultimately to interbreed. Imagine that first meeting, two groups separated by over 1,000,000 years of evolution, gazing at one another across a clearing. Their faces would have been strange brow ridges heavier, jaws thicker, bodies more robust, but their eyes would still have held the same searching curiosity that defines us. What followed was not conquest or replacement, but mixture. DNA evidence shows that the Neanderovan ancestors absorbed fragments of superarchaic genes into their own lineage, tiny traces of union preserved through time. Even more astonishingly, Denisovans later interbred with superarchaics again around 220,000 years ago, long after the original mingling, proving that these ancient populations endured in POC. Longer produce fertile offspring, but among our ancestors that barrier was porous. The ability to mix across vast stretches of time reveals something profound about humanity's nature. We were never defined by purity or separation, but by connection, adaptability, and shared life. It is tempting to imagine these encounters as fleeting small bands meeting by chance at river valleys, exchanging wary glances that turn to cooperation or kinship. A few children born of those unions carried within them the genes of both worlds, and through them those ancient lineages never truly died. When we analyze the DNA of modern humans today, we find traces of this layered inheritance ghosts within ghosts, where Denisovan segments contain fragments of even older superarchaic DNA, carried forward like messages hidden in bottles adrift across epochs. Each genetic signal is a relic of a real meeting between real people, their stories lost to time, yet written in our blood. As we trace these signals geographically, a haunting map begins to emerge. The early Neanderovans likely moved into Western Asia, crossing the corridors of the Middle East where Europe and Asia meet, while the superarchaics may have been scattered farther east, occupying lands that stretch from Central Asia into China and perhaps even Southeast Asia. Later Denisovan DNA suggests that these ancient peoples lingered especially in the east, perhaps in mountain valleys or forested refuges where they endured for hundreds of millennia. Their persistence tells us that human evolution was not a process of simple succession but of coexistence. Different species, different kinds of humans shared this planet at the same time, meeting not just through conflict but through the most intimate act of all. As scientists piece together the fragments of these forgotten encounters, certain fossils begin to glow with new significance. The massive skulls of Hexion and Dali in China, the long-faced fossils of Java, and the thick-boned remains from Jakurian all display combinations of features that seem too primitive for their age. Perhaps they are the remnants of the superarchaics themselves, the ones who met the Neanderovans and Denisovans on those ancient plains. If so, then the ghosts in our DNA have bones after all, faces shaped by the same hands that chipped the earliest stone tools and lit the first fires beyond Africa. In this view, the story of human evolution becomes less a straight path and more a braided river, with streams diverging and converging over deep time. Every bend and confluence represents a moment of contact, of shared life, of exchange. The Cima de los Huesos hominins of Spain, dated to around 430,000 years ago, stand as a key marker in this tangled network. Their bones already show the hallmarks of Neanderthals, but their genomes carry signals from even older lineages, proof that the ancestry of Neanderthals was already interwoven with the legacy of the superarchaics. Later, Denisovans would inherit this same mixture and add to it through new encounters in Asia, layering the past upon the past. The result is a genome like a palimpsest, written, erased, and rewritten by the tides of time. When modern humans finally left Africa and spread across Eurasia, they too joined this long pattern of mingling, absorbing Denisovan and Neanderthal DNA that had itself come from the superarchaics long before. Each time this happened, fragments of those ancient lineages flowed forward, preserved through endless generations. That is why today, the people of Papua New Guinea and Australia carry up to 5% Denisovan, DNA some of which traces directly back to the superarchaics themselves. It is as if their blood carries whispers from a million years ago. When we say that these genes survive, what we mean is that the people who carried them lived and reproduced enough for those traces to persist. It was not just genes that passed through time, it was memory, behavior, survival strategies, perhaps even subtle instincts shaped by those ancient worlds. Each stretch of DNA is a message from the deep past, saying that connection, not isolation, was our true inheritance. The superarchaics may be long gone, their bones scattered or lost beneath layers of earth, but through the intricate weaving of our genomes, their presence remains alive. They are not distant strangers in our story, they are part of our extended family, the unseen ancestors who remind us that humanity's greatest strength has always been its capacity to merge, adapt, and endure. In their unions with the Denisovans and Denisovans, they ensured that no lineage ever vanished completely. We carry their legacy in every cell, an invisible chorus singing through time that the human story was never about who replaced whom, but about how all of us, across ages and continents, remain connected by the fragile but unbreakable threads of life. As the dust of time settles, a clearer image of our origins emerges, not a straight line, but a tangled web of connection. The Denisovans, once ghostly traces in DNA, now stand revealed as explorers of mountains and forests across Asia, mingling with Neanderthals, modern humans, and even older lineages that had walked the earth for over 1,000,000 years. To the south, the hobbits of Flores lived their own quiet miracle, tiny, tool-making survivors who thrived for hundreds of thousands of years, proving that intelligence wears many forms. And in India, the massive Narmada skull tells of another branch, powerful and large-brained, bridging the gap between the ancient and the new. Together, they reveal that Asia was not the edge of evolution, but its beating heart, the place where humanity became many things at once. Imagine that world: Denisovans breathing thin air in the Tibetan highlands, hobbits kindling fire beneath jungle trees, and Narmada's kin stalking rivers in the shadow of monsoon storms. Different faces, different sizes, yet all driven by the same fire to endure. When modern humans finally emerged from Africa, they stepped into a world already alive with other kinds of people. And instead of replacing them entirely, they connected. Their children carried the genes of all who came before Neanderthal, Denisovan, and even superarchaic. Those fragments still live within us. In the breath of a Tibetan shepherd, in the resilience of an immune system, in the quiet hum of ancient code inside every cell. We are not the final chapter, but the living continuation of all who walked before. The hobbits, the Denisovans, the Narmada people, they were not mistakes or side stories, but our kin, proof that evolution was never about purity, but about adaptation and exchange. Every fossil, every strand of DNA tells us the same thing. Humanity's strength has always been its ability to mix, to learn, to change. The past was full of faces different from ours, yet somehow all familiar because they are still here, within us. Their extinction was not an end, but a transformation. We carry their breath, their courage, their endurance. So when we look back across that million-year web of crossings and returns, we find not distance, but family. The story of human evolution is not about survival of the fittest, it's about survival of the connected.